This video will explain the answer to the following question. Please feel free to pause or rewind the video if you need to review anything that was explained. When the plane had flown 4,150 feet from the airport, where it had taken off, it had covered a horizontal distance of 3,660 feet. What is the angle at which the plane rose from the ground to the nearest degree? So you can see from the diagram that the plane is taking off, so it's going up on an angle. That angle is what we want to find. So we're trying to find our input angle. This has been added to the diagram. It's just the height the plane is above the ground. It's not mentioned in your word problem, but I knew it was the height because I saw this right angle here. And remember that a right angle is always formed from the height and the ground in these types of problems. Okay, so in order to solve this problem, I need to ask myself two questions. The first question is, which trig formula will I use, so, ka, or toa? In order to determine that, I'm going to have to label my diagram. So I'm going to just erase what I labeled as the height above the ground, since we already went over that, so that I have some space to put in my labels. So the first label I look at is the opposite. Go to that input angle and go across from it, and that happens to be where the unknown height was. And then we go to the right angle and go across from it, and that is the hypotenuse. That happens to be the path the plane is taking during takeoff, 4,150 feet. Go back to that input angle and go next to it, and you'll see the distance along the horizontal ground that the plane has traveled so far, 3,660 feet. So I'm going to determine which formula is best to use, so ka or toa, from my labels. If you notice, the height was unknown, so there was no number here. It's not helpful. Meanwhile, the hypotenuse and the adjacent have numbers in them. So I need something using my hypotenuse and using my adjacent side. So my first example, so, it uses the opposite and the hypotenuse. Cosine, ka, it uses the adjacent and the hypotenuse, both that I need. That's good. Toa, tangent, is going to use the opposite and the adjacent. It's not okay because I don't have my opposite side. So I know the formula I'm going to want to use is my cosine of my input angle, and since I don't know what my input angle is, I'm making this symbol theta to represent it. That's going to equal my adjacent side over my hypotenuse side, which I actually have the measurements for, so I'm just going to take the liberty to plug them in really quick before we ask ourselves the second question. So adjacent is 3,660, and hypotenuse is 1,150. Okay, so my second question is going to be, am I solving for a side or an angle? And that's going to determine if I'm going to use regular cosine, where I solve with proportions and I figure out what the answer is, or if I use the inverse cosine, and that is if I have an angle. So I need to find what is the angle. See that word what? What is the angle? I'm trying to find an angle, so I'm going to use the inverse cosine. I am not trying to find the side, so I'm not going to use the regular cosine. So I'm going to switch up my color so it really stands out. And we want to do cosine of inverse instead. Now, the thing we're taking the inverse of, the thing you're going to put inside your parentheses, is what your ratio is, the adjacent side over the hypotenuse side. That's what you're going to type in your calculator. And once you do that, it will give you your answer for theta. Please make sure you're in degree mode, okay? And if you're in degree mode, it should work out fine for you. The only thing is, it's going to give you a long decimal, and you have to know to round it to the nearest degree. Nearest degree really means whole number. So I don't want any decimals, so I have to make sure I look at my whole number place when I round. So if you round correctly, your answer will be 28 degrees, which is the first choice.